In this video, we demonstrate how to capture and analyze the singing voice in real time, and in particular, how to measure vibrato. Vibrato consists in a periodic deviation of the pitch of the singing around its center frequency. This center frequency corresponds typically to a specific musical note. Vibrato is mainly characterized by two objective parameters, the vibrato frequency and the vibrato extension. The vibrato frequency tells the rate of the pitch variation and is measured in hertz, or cycles per second. The vibrato extension indicates how much deviation there is with respect to the central note. For example, if the vibrato extension is 0.5 semitones, then the deviation is 0.5 semitones above and below the central note, which means that the total vibrato signal occupies a semitone. In this video, the vibrato parameters will be estimated using a software named SingingStudio, whose main interface is shown on the left-hand side of the screen. SingingStudio was adopted and improved in the context of a research project supported by FCT, the Portuguese National Funding Agency for Science, Research and Technology. The acronym of the research project is HEARTS, and the involved partner institutions are identified in the lower right side of the screen, as well as the website where detailed information can be found. In order to have full control over the singing voice to be tested, we will use the Madde software, whose main interface is on the right-hand side of the screen. Madde was developed at the Royal Institute of Technology in Sweden, also known as KTH, and synthesizes singing in a very flexible way, including the possibility to change the vibrato in real time. Using Madde, we synthesize a D2 note whose vibrato has a frequency of 6 Hz and whose extension is 0.4 semitones. Then, we synthesize an A-sharp 2 note where the extension remains as before and the vibrato frequency changes suddenly from 6 Hz to 3 Hz. Next, we have a F-sharp 2 note with the same vibrato parameters of the previous one. The next note is a A2 and its vibrato extension increases to 0.8 semitones on the second half of the note. Finally, the last note is E2 and keeps the vibrato parameters of the previous note. After the singing has been recorded, we select the vibratos detection button in SingingStudio, so that vibrato segments are automatically detected. The regions of the singing where the vibrato is detected become highlighted using the green color, and markers appear signaling the start and end of each vibrato segment. These markers allow the user to manually adjust the segments. Also, just next to the highlighted segment, a button exists that is identified with the letter V. After clicking on this button, a pop-up window emerges that contains specific and statistical information about a vibrato. Specifically, on the top left-hand side of this window, a detailed plot is shown of the accurate pitch analysis of the singing. Just below it, detailed representations of the vibrato frequency and of the vibrato extension are also shown. Statistical information is also displayed on the right-hand side of the pop-up window. We can confirm for the last segment of vibrato that the estimated vibrato frequency is 3 Hz, which corresponds to the expected value, and that the estimated vibrato extension is 0.76 semitones, which is very close to the correct value of 0.8 semitones. Now, let's check the vibrato parameters for the vibrato segment in the middle. Here, after clicking the V button, we conclude that SingingStudio estimates the vibrato extension has 0.39 semitones, which is very close to the true value of 0.4 semitones. Finally, let's check the vibrato parameters for the first segment. Here, we conclude, after clicking on the V button, that SingingStudio provides an estimated vibrato frequency of 6.01 Hz, which essentially equals the true value of 6 Hz, and an estimated vibrato extension of 0.35 semitones, which is reasonably in line with the true value of 0.4 semitones. To learn more about SingingStudio and get a demo version, please visit the indicated website. To get a copy of Madde software, please visit the KTH website as indicated. Try it for yourself and have fun!